Good morning, everybody. Here we are, Tuesday, the 7th day of April. And today we are going to be talking about secant segments. And your essential question will be, how do I use secant segment rules to solve circle problems? Alright, so let's define a secant segment. A secant segment is just what it says it is. A secant segment is a segment of a secant. So if we've got a circle and secant 1, secant 2, and we've got points A, B, C, D, and E, A to B, A to B. I guess we're not going to cooperate today. A to B is a secant segment. B to C is a secant segment. A to D is a third secant segment in this diagram here. And D to E is a secant segment. Alright, so coming up in just a minute, keep in mind this segment right here. This segment from the point of intersection of the two segments to the other side of the circle, that segment length would be equal to AB plus BC. And this segment length would be equal to the length of segment AD plus the length of segment DE. And while we're here, let's just talk about secant segment theorem and what it states. And we can just use this same diagram for the secant segment theorem. It says if two secants intersect in the exterior of a circle, then this entire segment AC times this exterior segment AB will be equal to the entire segment AE times the exterior segment AD. Okay? And again, be very careful here. it's going to be this entire segment times this outside piece. That will be equal to this entire segment times this outside piece. Okay? So let's do a few examples now. So here's a secant and another secant, and they both intersect outside the circle at point R. And we've got points T, U, S, and V. And here's our segment lengths. Okay? So what the rule says is that this entire piece times this outside piece is going to be equal to the entire piece of the second secant times its exterior piece. So what we've got now is this entire top secant, RU, that's going to be equal to x plus 9 times the outside piece, which is x, is going to be equal to the entire second secant, which is 4 plus 5, times its outer piece, which is just the 4. So here's what we've got. On the left hand side now we have to distribute. We've got x times x, which is x squared, and we've got 9 times x, which is 9x. On the right hand side, our 4 plus 5 is 9 times 4 is 36. So we're going to end up with a trinomial here because we're going to subtract 36 from each side. And what we're left with is x squared plus 9x minus 36 being equal to 0. And I know you all remember it. You'll be using the quadratic formula today and tomorrow and on your quiz to solve these trinomials so that you can determine these secant segment lengths. So remember, the quadratic formula states that x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all divided by 4 times a. So remember, in this trinomial, your a value is what's in front of the x squared, your b value is what's in front of the x, and your c value is what's between the x and the equal sign when the equation is set equal to 0. So let's do some substitution and solve for x now. So in this case, our x is going to be equal to the opposite of b, so negative 9 plus or minus the square root of our b squared is 9 squared minus 4 times our a value, which is 1, times our c value, which is negative 36. And all of that gets divided by 2 times a, which is 2 times 1. Alright, so we're going to clean this up. Our x is going to be equal to negative 9 plus or minus. Alright, underneath our radical, we've got 9, let's see. Underneath the radical, we've got 9 squared minus 4 times negative 36 So we've got 81 minus 4 times 36. 4 times 36. That's 144. So we got 81 minus negative 144, all divided by 2. And again, we're going to clean this up. So our x is equal to negative 9 plus or minus the square root of 81 minus negative 144. Remember, that's keep, change, change. So that's 81 plus 144. So 225 divided by 2. Now this plus or minus means to do the final step twice. So x is going to be equal to negative 9 plus the square root of 225 divided by 2. And x is also going to be equal to negative 9 minus the square root of 225 divided by 2. So 9 negative plus 15 divided by 2 is 3. And our second value is going to be negative 12. Alright, so since we're talking about x here, and x is this external secant segment, it cannot be negative, so our x is equal to 3 in this case. That's your rule as it relates to secant segments and how to solve the problem using the quadratic formula. So our second example today is going to relate to tangent segment, and here's an example and the rule for tangent segments. In this diagram we have a tangent and a secant that intersect outside of a circle. So here's our, we got point A, B, and C, and then point D down here as a point of tangency for this tangent and circle. Alright, so if a tangent, not a tam, computer's a little slow right now. There we go. If a tangent and secant intersect outside a circle, then, okay, this rule is very similar to the last one, if not the same. Then, in this case, this entire segment AC times its outside piece AB is going to be equal to this whole tangent length times itself. So that would be AD squared. Alright, so again, it's the entire secant length times the outside piece of the secant is equal to the entire tangent length squared. So let's do a problem and see how this works. Here's our circle. Our tangent. And our secant. Alright, P to Q is 8 units. S to R is 7 units. R to Q is X units. Okay, so based on the rule, the entire length of the secant, so in this case we've got X plus 7 times the outside piece, which is X, is equal to the tangent squared. Alright, so now we have distributive property on the left hand side. So we've got X times X, which is X squared. We've got positive 7 times X, which is positive 7X, and that's equal to 64. So we're going to get all the terms on the same side of the equation. We're going to do that by subtracting 64 from each side. So our X squared plus 7X minus 64 is equal to 0. And again, we have another trinomial. So we're going to solve this trinomial using the quadratic formula. So same quadratic formula as the previous problem. So our X is going to be equal to the opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So X is equal to negative 7 plus or minus the square root of all of this under the radical. 7 squared minus 4 times 1 times negative 64. All of that under the radical is equal to 305. And then we're going to divide it by 2. So we're going to break this apart and we're going to do it twice. Our X is going to be equal to negative 7 plus the square root of 305 divided by 2, and negative 7 minus the square root of 305 divided by 2. After you take your negative 7 plus your square root of 305, be sure to hit the equal sign and then divide by 2. Same with when you're subtracting. So on the left side, our first value of X is going to be equal to 5.2. Our second value of X is going to be equal to negative 12.23. Since our secant segment cannot be negative, our 5.2 is the value that we're going to use. We're not going to use the negative 12.23. Alright, so those are two examples that relate to the rules regarding secant segments and tangents and how they relate to each other. And now I'm going to give you some practice problems to do today. Please remember to review your notes and review the example problems. Then complete the practice problems, answer your focus question or your essential question, and then go on focus and do the online assignment. This Friday is a holiday, so your study guide will be tomorrow and your quiz will be on Thursday this week. So here's your practice problem number 1. That's a tangent down there, guys. Sorry. And all these solved problems, we're going to solve for x. And we're going to round to the nearest tenth. Alright, here's your last problem for today. Okay, please be careful, double, triple check your work before doing the focus problems. Some of these steps are tedious and careless mistakes can be made, so please, like I said, double check your work before you do your focus problems. And have a great rest of your day, and I will see you tomorrow.